Hello everyone and welcome back to Clear Creek Solutions hydrology education videos. In this video we're going to cover wetlands, what they are, what their functions are, and what some of the software and tools we use to keep wetlands from being either under-provided with water or over-provided with water. We're going to go over all of that here. We have a guide called the Ultimate Hydrology Guide, which you can find in the description box down below, which gives you an overview of the different kinds of hydrologies that are currently being used in the field and utilized by different jurisdictions. So let's get into the presentation here. So wetlands are defined as areas where the soils are covered by water. This water is present year-round and greatly impacts how the soil develops and the wildlife present. So the presence of aquatic plants is what separates wetlands from other land use areas and environments. So because we have these different plant life and different aquatic organisms that are present in this certain environment, that's what's going to make it a wetland, different from just standard pasture or lawn. It's just overall a different environment for these organisms to grow in. So what are some general wetland classifications? Well, we have coastal/tidal wetlands, which are adjacent to coasts and water bodies. The wildlife in these wetlands have adapted over time to coastal climate and conditions. This can include swamps, marshes, and salt-loving shrubs and trees. Then inland and non-tidal wetlands, these wetlands are more commonly floodplains along rivers and streams, and these can include marshes and meadows, and these wetlands are often seasonal due to their inland nature. So what are the types of wetlands and classifications that we can see in a place like Western Washington? Well, there are category 1, 2, 3, and 4 wetlands, and it's a gradation on the quality of that wetland, how much it can be impacted, and how much it requires mitigation in order to maintain its current condition. So here's the different categories. For wetland category 1, this represents a rare or unique wetlands or wetlands that are more susceptible to disturbance. It's more common than category 1 wetlands, but still require a high degree of protection. And then moderately functional wetlands would be category 3 and can be replaced with a well-planned mitigation design and project. And then a category 4 is a heavily disturbed wetland that can be either replaced or improved entirely. So in terms of the ability to tamper with these different wetlands, wetland 1 are much rarer and they require a lot of care because they're very susceptible to disturbance. And the wetland 4's category 4 could be heavily damaged and through the project could actually be improved if the right mitigation measures are utilized. So the 938,000 acres in Western Washington are made up of wetland area, and 5.5% of the contiguous United States is occupied by wetlands. So here's some wetland types. Here's the general categories. On the left, you can see what a coastal wetland looks like. And on the right, you can see what an inland wetland looks like. You can see the left one, it looks like more like a marsh or a delta area. And the inland wetland is going to be that water body there, but occupied and more seasonally adjusted based on the wildlife surrounding it and the land use. You can see the different gradations of wetlands, category 1 to category 2, and more to damaged wetlands in category 3 and category 4. So how is wetland modeling criteria in Western Washington applied? Well, there's two different methods that we can use. Method 1, which is monitoring wetland stage modeling. This method requires data collection specific to the wetland, as well as continuous simulation modeling to demonstrate that a proposed project will not negatively alter the wetland hydrology. Then there's site discharge modeling, and this method requires continuous simulation as well of the runoff from the TDA to demonstrate that the changes in total discharge volume to the wetland will remain similar to the pre-development conditions. So there's a high emphasis on keeping that volume discharge the same in order to preserve the wetland. So how do we go about wetland hydro period modeling process? So this is the detailed process that we follow when using wwhm 2012. First, we put in the land use for both the pre-developed and mitigated scenarios. We set up our analysis by placing in dummy trapezoidal pond elements to monitor the amount of input volume. We determine what those wetland input volumes are over the entire time series and model run. And then we make modifications to our project site, the mitigation measures based on those results, so we can even out those volumes and input volumes. So you can see here we set up the land use area for both scenarios to calculate the wetland input volumes. And then we go about running an analysis to determine the monthly fluctuations and daily fluctuations, and then we make adjustments. So you can see here that we'd have to make significant adjustments to our project so that our monthly values can pass for the project and they don't fail. Preservation of wetlands are very critical to the health of watersheds. So it's not just about preserving the nature and the wildlife in those wetland areas, but actually it is very important to maintain the health of the watersheds as well for today and in the future. So by striking a fine balance between development and preservation, watershed health can be maintained. Here's some of the works that we reference. If you have any questions about wetlands, leave it in a comment down below. Like I said, you can download that ultimate hydrology guide in the description as well. Please like and subscribe to the channel. And anyways, we'll see you guys next time.